Okay, best regrets. We introduce ourselves. We are Carol Puentes, Justin Moreno, and Santiago Galvis, and today we will talk about the electronic configuration.
Hello guys, today we will explain the electronic configuration.
But what is the of the electronic configuration? The electronic configuration is the way in which the electrons of an atom are distributed, and these are ordered in the different levels and sublevels of energy. And what are these levels and sublevels? The levels go from 1 to 7, and these are ordered. The ones that divide the periodic table in 7 periods indicate to energy and size. The sublevels are cataloged by 4 to the letters S, P, D, and F, and the index fit and determinate number of the electrons, the orbital. S2 in the P6, in the F10, and the F34. Remember that only fits and determinate number of electrons in each orbital, and we can now overpass this one. But first, we have to know how to obtain the number of electrons, and therefore the atomic number. Let's take example. According to the periodic table, this oxygen has atomic number of H, which they have H protons, and the sum of the charges to be 0. We require H negative charge of H electrons. Comment the number of electrons the oxygen has. We proceed the electronic configuration of the disk. We will begin in the first diagonal. We see that with the s orbital and the level, we write down the level and the orbital, and remember the number of electrons that if in each orbital. In the second diagonal, we find the sublevel S and the level 2. We write down the number of electrons that if we know which the three diagonal, we will find p orbital. We write down this which the number of electrons that finish making the summation, which it has 10 electrons, and x for h. We will make a modification orbital p placing 4 and giving of the sums h electron. Remember, importantly, not exceed the number of electrons.
Now we're going to continue with locate an element from its electronic configuration. We're gonna locate an element with atomic number 21. The first step is to make the electronic configuration. As a second step, the electronic distribution is gonna be performed. The number of orbitals is represented by the lines, and their electronic capacity is represented by up and down arrows. First, the upward arrows are filled in, and then the downward arrows. For the location of the element, the highest energy level that is in the configuration is used as its period. For the group, the last energy sublevel and the sum of the electrons in the last two energy levels are used. In this case, it ends at sublevel D, which means that is in group B. The sum is 3, so its group is 3b. Now we proceed to place the element on the periodic table. In this case, it would be the scandium with atomic number 21.
We begin with boron with atomic number 5. The respective orbitals are made and term filed. With this, we can observe that this has two energy levels. Okay, this has two full orbitals, one semi-full orbitals, and two empty orbitals. In this second example, we have aluminum with atomic number 23. Its respective orbitals are made and filled according to the atomic number. Okay, with the above, it is determined that it has three energy levels. It has 6 full orbitals, one semi-full orbitals, and two empty orbitals. Okay, now we talk about examples with ions. We present the oxygen ion with atomic number 8 and negative energy -2. This means that the oxygen is gaining 2 electrons. When doing the sum, it is necessary that the oxygen has 10 electrons. The orbital process is done, and it has two energy levels, 5 orbitals, and non-semi-full or empty orbitals. Okay, with this we conclude with the explanation of electronic configuration. Thank you for listening. Bye.